Hi, we are from K Division Team 16. Our course project is Automatic Titrating Robot. Team members are Lakshman, Hemant, Santosh and Vinayak under the guidance of Mr. Sandeep R.K. This is our problem definition. In problem definition, we are taking objects, constraints and function tree. Under notification, sensor color indicate completion, handle burette, hold burette, dispense solution, rotate now. Under handle conical flask, hold conical flask, start shaking, stop shaking, and casing. This is function clustering. Subsystems identified: burette handling unit, and second one conical handling unit. Last one is power unit.
We designed about 4 concepts for our course project. In design 1, we have used mechanical arm for holding the pivot and a rectangular platform for holding the conical flask. Here we have used servo motor for rotating the knob and a DC motor for shaking the conical flask using cam mechanism. Completion of the process is indicated by a buzzer when the color sensor senses the change in color. In design 2, we have used robotic arm for holding the pivot instead of mechanical arm, and a circular platform for holding the conical flask. Here we have used stepper motor for rotating the knob and a DC motor for rotating the platform so that the solution in the conical flask is shaken. In design 3, we have used mechanical arm for holding the bucket and a rectangular platform for holding the beaker. Here also we have used stepper motor for rotating the knob of the bucket and DC motor for stirring the solution in the beaker during the process of titration. Here also color sensor senses the color and a buzzer indicates the completion of the process. In design 4, we have used mechanical arm for holding the bucket and a circular platform for holding the conical flask. Here we have used servo motor for rotating the knob and DC motor is used for shaking the conical flask. Here we have used linkage mechanism for shaking the conical flask. And we have chosen the design 1 as our final concept for our course project.
3D model of the entire system. This is DC motor, base plate of the conical flask, conical flask holder, color sensor, base plate of the conical flask, cam, burette stand rod, base plate of the entire system, and assembly. Circuit diagram of the entire system. This is Arduino and this is servo motor which rotates the knob of the burette, and color sensor used for to sense the color, and DC motor used for cam mechanism. Flowchart. When titration process starts, servo motor rotates the knob of the burette. If color changes, servo motor rotates in anti-clockwise direction. DC motor stops rotating and buzzer on. If not, DC motor rotates continuously to shake conical flask until color changes.
Here we are coming with a bill of material required for the entire system. In that, first one is microcontroller and the servo motor and color sensor and conical flask and buzzer burette stand, burette holder, burette, and conical flask, foam sheet, breadboard, acrylic sheet, and all the nuts like M5, M6, M4, and M8. And the microcontroller is made up of Arduino Mega 2560, and we are using digital pin 54 and log pin 16. And for servo motor we are using SG9090 with the 180-degree rotation. And for color sensor, the specification we are using TCS230 color sensor, and a conical flask with a maximum volume 500 ml, and a buzzer with the sound type is continuous beep. Burette stand which is made up of the steel and foam with the height 750 mm and the base is 200 into 200 mm. Burette holder which is also made up of the steel with a 20 mm, and the burette which is made up of the borosilicate glass with the maximum volume 50 ml, and the conical flask which is also made up of the borosilicate glass and with the maximum volume 500 ml. And next with the foam sheet which is made up of the polyurethane with the thickness 10 mm and 20 mm with the color white. And after that, breadboard which is made up of the plastic which has many connections. And after that, acrylic sheet which is made up of acrylic with a 2 mm, and all the nuts like M5, M6, M4, and M8 which is made up of the iron. The specifications are like 100 mm, 80 mm, 50 mm, 100 mm, and 30 mm. And after that, we are coming with a motor sizing and battery sizing of the entire system. In that, we need 2.94 Newton force and 5.88 Newton centimeter tension, and then 9.2374 watt power. After that, we are coming with the functional specification of the entire system. In that, the functions are like holding the burette, holding the conical flask, holding all the components, sense the color, storing the titrant, defense the solution from the burette, shaking the conical flask, and last but the least, indicator. And the specification of the functions are like for holding the burette, the height of the building and the stand is 50 centimeter and made up of the steel with the burette holding clamp. After that, for holding the conical flask, is a movable square base with a 20 into 50 centimeter made of the iron board. After that, for holding all the component, we are using square base of the 50 into 50 centimeter made of the foam board. And for sense the color, we are using color sensor TCS230 with the dimensions 2.5 into 2.5 centimeter. After that, for storing the titrant, we are using burette with a 25 ml capacity, and for storing the titrant, we are using conical flask of the 75 ml capacity. And after that, for defense the solution from the burette, we are using servo motor of SG90. And after that, for shaking the conical flask, we are using DC motor with a cam mechanism. After that, last but the least, for indicator, we are using buzzer with a sound type continuous beep.
Modeling and simulation. This is the code of our model. When titration process starts, servo motor rotates in one direction up to 90 degree and DC motor rotates in one direction. If there any motion, PIR motion senses the motion and stops the DC motor. If not, servo motor rotates up to 90 degree. When buzzer on, servo motor rotates in anti-clockwise direction.